everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal. Today topic is complex matrices. Under the complex matrices, we are going to discuss that Hermitian, Skew Hermitian matrix only. Here, first of all, we need to understand what is the meaning of the complex matrices. Actually, the meaning of the complex matrices are nothing but whenever the matrices are, the elements are which are involving, that is a complex values only. That means complex elements only. If it is a elements are not a complex, such type of the matrix is not a complex matrix. That means including at least in each and every, that is a matrix, compulsory at least one element is required to satisfy complex. Then only the matrix is said to be is a complex matrix. And based upon if it is satisfied the complex matrix, then only we are going to discuss this is the methods, that is the Hermitian and Skew Hermitian matrix. And before going to discuss the Hermitian and Skew Hermitian matrix, first of all we need to understand what is a conjugate of a matrix. That is very important to understand. The conjugate of a matrix is nothing but whatever the given matrix on this in that matrices, whenever the elements are like plus I minus I, by applying the conjugate such type of on the given matrices, that is a plus I changed to like minus I and minus I changed to plus I. That is the meaning of the conjugate of a matrix. Here it is denoted, that is a symbol A bar. That is the meaning of the conjugate of a matrix. Here, how to define the definition of the conjugate of a matrix. Therefore, if the elements of a matrix A are replaced by their conjugates, then the resulting matrix is defined as the conjugate of the given matrix. Clearly, that is denoted, that is A bar. That is A bar. For example, it is a given matrix is a considered, that is a 2 by 2. Like 2 plus 3i, 5, 6 minus 7i, 5, minus 5 plus I. By applying on this matrix, that is a conjugate, according to this definition of the conjugate of a matrix, that is here plus 3i is changed like to minus 3i. That is 2 plus 3i changed to like 2 minus 3i. The second value is a real value only. Therefore, real value it is not applicable. Therefore, the real value is as it is, that is 5. The second row 6 minus 7i is changed to, that is 6 plus 7i. Because minus I is changed to plus I, that is 6 minus 7i is changed to 6 plus 7i. And last element is also minus 5 plus I is changed to minus 5 minus I. And based upon this is the conjugate of a matrix. Now we are going to discuss what is a conjugate transpose of a matrix. That means when the given matrix by applying the conjugate, and after that once again, when we are going to apply, that is a transpose, that is called as a conjugate transpose of a matrix. Otherwise, this is also indirectly it is called as a transpose of a conjugate of a matrix. That means by applying the conjugate and latter, that is a transpose. Similarly, by applying the first transpose and after applying the conjugate, there is a no change. That is the meaning of the conjugate of a transpose of a matrix is equal to, that is a transpose of a conjugate of a matrix. Both are the same the matrix. And according to this conjugate of a transpose of a matrix, it is denoted the symbolically, that is a power of theta. Sometimes that a power of theta is also denoted a star. Either a star or a power of theta, otherwise a conjugate or transpose, otherwise a transpose or conjugate. And based upon this is the conjugate of a transpose of a matrix. These are the 4 conditions we need to remember. One is the if A power theta and B power theta are the transpose of a conjugate of A and B respectively, then A power theta or whole power theta is equal to A. Second one, that A plus B or A plus or minus B whole power of theta is equal to A power of theta plus or minus B power of theta. Here plus or minus is corresponding like A plus B whole power theta is equal to A power theta plus B power theta. And similarly, A minus B whole power of theta is also changed to A power theta minus B power theta. And third one, if it is a considered K is a constant, that is either it is a complex constant on that K into A whole power of theta. If it is a K is a complex value, for example, by applying K power theta is also changed to K bar into A power of theta. And finally, if it is a AB whole power of theta is equal to B power theta into A power of theta. These are the four conditions we need to remember, that is a conjugate of a transpose of a matrix. Otherwise, that is a transpose of a conjugate of a matrix. And based upon these are the fundamental basic concepts, that is a conjugate of a matrix and conjugate transpose of a matrix. Now we are going to discuss, that is Hermitian matrix. Here Hermitian matrix is nothing but based upon the conjugate of a transpose of a matrix. It is a given the matrix. That means A power of theta is equal to, that is a A. That means when we are going to applying on the given matrix, that is a conjugate of a transpose of a matrix is equal to the right side is also obtained the given matrix. Such type of the definition is called as a, that is Hermitian matrix. Therefore, A power of theta is equal to A is called the conjugate Hermitian matrix. And for example, if it is a consider A is equal to the elements are 4, 1 plus 3i, 1 minus 3i, 7. By applying that is a conjugate on the given matrices, that is a is equal to A bar, that is equal to 4, 1 minus 3i, 1 plus 3i, 7. And again applying the transpose on this matrices. Therefore, that is nothing but interchange the rows and columns. Therefore, 4 1 minus 3i is changed to 1 first column, that is a 4 1 minus 3i. The second row is changed to, that is a second column, 1 plus 3i, and again the 7 last value is a 7. And here A power theta is equal to, you obtain the given matrix. Therefore, this matrix is clearly suitable for the Hermitian matrix. And under this, that Hermitian matrix, these are the node condition we need to remember. One is the element of the principal diagonal elements of the Hermitian matrix are clearly satisfied the real value. Second one, a Hermitian matrix over the field of a real numbers is nothing but a real symmetric matrix only. Because A power theta is equal to A, therefore always the given matrix of the, if it is a is a Hermitian, automatically the matrix is satisfied, that is a Hermitian symmetric matrix only. Similarly, the skew Hermitian matrix. The skew Hermitian matrix is also related to, that is a Hermitian matrix, but whereas the Hermitian is a power theta is equal to the given matrix. But according to here, that is a skew Hermitian matrix is equal to, that is a negative of the given matrix clearly satisfied. Here, for example, if it is a consider A is equal to, that is a 2 by 2, that is a minus 3i, 2 plus i, minus 2 plus i, last value is a minus I. First, when we are going to applying, that is a conjugate, that is a values are changed to 3i, 2 minus I, minus 2 minus I. Again, we need to apply, that is a transpose of the matrix. The matrix is reduced to, that is a 3i, 2 minus I, minus 2 minus I, and again I value. Therefore, while we are observing this matrices, it is a negative of the clearly given matrix is a satisfied. Therefore, it is a condition is a, that is Hermitian matrix, that is nothing but A power theta is equal to minus A, that is nothing but the conjugate of a transpose of a matrix is equal to the negative of the given matrix. Here, one of the important property based upon under the Hermitian and skew Hermitian matrix, it is a every square matrix is uniquely expressed as the sum of the Hermitian matrix as well as there is a skew Hermitian matrix. Under this is also related to this one under the real matrices. The one other property, that is every square matrix can be uniquely expressed as a symmetric and skew symmetric matrix. But here we are going to discuss the under the complex matrices. Therefore, here also every square matrix can be uniquely expressed as a sum of, that is Hermitian as well as the skew Hermitian matrix. Therefore, if it is a consider A plus A power theta whole power theta is equal to by the property of that is a power theta plus a power theta whole power theta, which is equal to a power theta plus a power theta whole power theta is also, we know that the node condition a only. Therefore, a plus a power theta whole power theta is changed to a plus a power theta. Therefore, it is a given matrix is clearly satisfied. Therefore, this matrix is said to be Hermitian matrix. That is a 1 by 2 into a plus a power theta is also Hermitian matrix, because of that 1 by 2 is a constant multiplication. Therefore, if it is a plus a power theta is Hermitian, automatically 1 by 2 into a plus a power theta is also Hermitian. Similarly, it is a consider a minus a power theta whole power theta is equal to, according to by the property, that is a power theta minus a power theta whole power theta. And again, we know that the property that is a power theta whole power theta is equal to a only. Again, when we are going to take out common negative of the right side, that is a minus into that is a minus a power theta. Therefore, it is clearly satisfied a minus a power theta whole power theta is equal to the negative of the a minus a power theta. Therefore, it is clearly according to the Skew Hermitian matrix is satisfied. Therefore, it is a minus a power theta is a Skew Hermitian. Automatically, when we are going to multiplication with the scalar, that is 1 by 2. Therefore, 1 by 2 into a minus a power theta is also Skew Hermitian matrix. Therefore, according to this, clearly that is a if a sum of Hermitian every square matrix can be uniquely expressed as a sum of that is a Hermitian matrix and also Skew Hermitian matrix. Next one, if it is a is equal to this is a 3 by 3, then we need to show that a is a Hermitian into IA into a is a Skew Hermitian matrix. And as we know that if it is a is a Hermitian, we need to show that a power theta is equal to a only. First of all, the given matrix is a consider a is equal to the corresponding values are that is a 3 by 3, 3, 7 minus 4i, minus 2 plus 5i, 7 plus 4i, minus 2, 3 plus I, minus 2 minus 5i, 3 minus I, 4. That is a given matrix. Now we need to find out what is a power theta. According to by definition of a power theta is equal to, first we need to apply what is a conjugate. According to the conjugate of a matrix is nothing but we are going to replace the values are plus I is equal to minus I is equal to plus I only. Therefore, when we are observing in this matrices, here the complex values are clearly satisfied. The first row, second row and third row. Therefore, the 3 that is real, no problem. The 7 minus 4i is changed to 7 plus 4i. Minus 2 plus 5i is changed to minus 2 minus 5i. The second row 7 plus 4i is changed to 7 minus 4i. Minus 2 is the real value. Therefore, minus 2 we are not changing. And 3 plus I is changed to 3 minus I. The last row is changed to that is a minus 2 plus 5i, 3 plus I and 4. But once again, we need to apply on this conjugate that is a transpose, because we need to verify this is the Hermitian matrix. For the purpose of the Hermitian matrix, the definition is a conjugate of a transpose. Just now we completed, it is a conjugate only. And again, we need to apply that is a transpose of this is the conjugate. Therefore, according to the transpose of the matrix is equal to, therefore, interchange the rows and columns. Here, by applying the rows, that is a interchange the first row, second row, third row, is changed to like first column, second column and third column. According to by using these operations, clearly the given matrix is reduced to given matrix. Therefore, a power theta is equal to clearly satisfied, that is a only. Therefore, it is satisfied, that is a is a Hermitian matrix. And similarly, we need to verify that I into A is also Skew Hermitian matrix. And according to the definition of the Skew Hermitian matrix, for example, if A is a Hermitian, Skew Hermitian, A power theta is equal to, we need to prove that minus A. But here, we need not only A, the problem is given I into A is a Skew Hermitian matrix. Therefore, we need to prove that I into A of whole power of theta is equal to minus half into I into A. We need to remember in our mind, we verify that second part that I into A is a Skew Hermitian matrix. Therefore, here the given matrix is clearly given that A is multiplication with IA, but here IA is treated as assume that is a B. Therefore, we need to show that it is a B power of theta is equal to minus of that is a B is a value. If it is a satisfied minus B, then it is B is a Skew Hermitian matrix. Therefore, first of all, we need to find out what is a B, that is I into A. According to that given matrix A is multiplication with I on the total matrix. Therefore, entirely the matrix is reduced to like IA is equal to 3I 4 plus 7I minus 5 minus 2I, and second row is also like minus 4 plus 7I minus 2I minus 1 plus 3I. The third row is changed to 5 minus 2I 1 plus 3I 4I. Now we need to find out our concept is a B power theta. First of all, on this B we need to apply that is a conjugate according to the first condition. Therefore, once again by using the conjugate is nothing but that plus I is equal to minus I and minus I is equal to plus I. That is replacement of only in the complex value. We are not applying, not possible to do that on the real value. Therefore, based upon this one, in here, each and every value is in each and every row is involving, that is a complex. Therefore, here change it to like all the rows, that is R1 row, R2 row and R3 row. And again, after getting this is the B bar, now we need to apply that is a B bar whole transpose. That is nothing but interchange the rows and column on the B bar, that is a conjugate of a matrix. Therefore, R1 row is changed to like R1 column, R2 is row changed to R2 column, and R3 row is changed to R3 column. Therefore, it is clearly B power theta. In this matrices, if you are going to take out common, that is a negative in this total matrices, that is clearly we obtain that is a negative of B is satisfied. Therefore, here B is equal to I into A is a Skew Hermitian matrix. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.